This is section 7.2. We're going to be graphing lines. If you can put an equation in the form ax plus by equals c, the graph is going to be a straight line when you graph it. As long as a and b are not both 0, we call these linear equations in two variables. The x-intercept is the point where the graph crosses the x-axis. What you need to know is to find the x-intercept, y is going to be 0. To find the x-intercept, y is going to be 0. To find the y-intercept, x is going to be 0. Graph 3x plus 2y equals 6 by finding the intercepts. Well, to do that, you're going to do an xy chart. Easiest way to graph if an equation is in standard form, which means the x and y are on the same side. Easiest way to do that, quickest way, is to do an xy chart. It's not the only way to graph. What you're going to do is you're going to take 0 and you're going to plug it in for x. So in order to graph a line, you need 2 points. So we're going to find 2 points. And the first point we're going to find is that x is going to be 0. So 3 times 0 is 0. We don't need the 0. We get 2y is equal to 6, or y is equal to 3. So you're going to put a point at 0, 3, right here. And this is the y-intercept because it's on the y-axis. Okay, now we need another point. So we need 2 points in order to graph a line. So what we're going to do is we're going to plug in 0 again, because 0 is the easiest number to plug in. We're going to plug in 0 again, only this time instead of plugging in 0 for x, because we already did that, we're going to plug in 0 for y. So 2 times 0 is equal to 6, and solve. 2 times 0 is 0. And you get x is equal to 2. So we're going to put a point at the point 2, 0. And this is the x-intercept because it's on the x-axis. When you have 2 points, you can connect them and you have a line. Now, some of you see patterns where there is none. You see the 3, you see the 3, you see the 2, you see the 2, and so you think you're just going to be able to just put points wherever you see these numbers here. That's more of a coincidence than anything else. You do have to actually go through the process of plugging the numbers in and solving. Do not think that because we have a 3 here and a 2 here that it's always going to be the 0.0320. You got to watch that because that's not always the case. This is more coincidence than anything else. Slope. Another way of saying slope is rise over run. The formula for slope, and we always use m, subtract the y's, subtract the x's, and the y's go on top. Find the slope. If I have 2 points, and it's not on a graph, there's a couple different ways. Quickest way when you get 2 points is to actually use the formula. So I'm going to take my second y value, which is 4, subtract my first y value, which is -1. Make sure you have the subtract, make sure you have the negative. You need both of them. On the bottom, I'm going to take my x's. So I'm going to take my second x value, subtract my first one. Now, you can reverse that. You can call this point 2 and this point 1. It doesn't matter as long as these two numbers come from the same point. They have to come from the same point in order for this to work. Remember, when you're subtracting a negative, it's the same as adding a positive. On the top I have 4 plus 1, which is 5. On the bottom, Negative 2 plus 3 is 1. You would simplify that and get a slope of 5. The other way to find the slope is to actually plot the points and do rise over run, so that will work as well. We talked about standard form briefly, where the x and y are on the same side, but if x and y are on different sides, we have what we call slope-intercept form. The reason why we call it slope-intercept form is because this number that multiplies the x is the slope, and this gives us the y value for the y-intercept. So for example, if I have y equals 2x minus 4, the 2 will give me the slope. It's not 2x, it's 2. 2 is the slope. There should be no x's in the slope. When you tell me the slope, it should be a number. And the y-intercept, it's not negative 4. It's actually 0, negative 4. Graphing using the slope and the y-intercept, I kind of talked about this in 7.1. But you're going to plot the point 0b. You're going to do that first. So take this number and put it on the y-axis. Then you're going to use the slope, or rise over run, to find your second point, and you're going to connect them. So for example, if I want to graph y equals 2/3 x plus 2, my b is 2, so on the y-axis I'm going to put a point at 2. My slope is 2/3, which is a positive 2 over a positive 3. So that means the top number tells us up or down, the bottom number tells us left and right. So we're going to go up 2 to the right 3 from the point that we already plotted. Don't go from 0, 0. Go from the point we already plotted. We're going to go up 2 to the right 3 and connect them. All right, suppose you have 2x plus 5y equals 0. It is in standard form. Traditionally, we would use an xy chart to graph. So if we were to do an xy chart, and I plug in 0 for x, I get 2 times 0 plus 5y equals 0. 5y equals 0, divide by 5, and you get y equals 0. What would happen if I were to plug in 0 for y? Well, you're going to get 0 for x. So this only gives us one point, which is not enough to actually graph the equation. So, and the reason why that happened was because of this being a 0. If that were any other number, we wouldn't have run into that. So what we're going to do is we're going to actually graph using the slope and the y-intercept. But again, the only way we can do that is if we have the x and y on opposite sides, if we solve for y. So I have 2x plus 5y is equal to 0. I need to get my x on the opposite side of the equal sign, so I'm going to subtract it from both sides. And I need to get my y by itself. I'm going to, I need a 1y, not a 5y, so I'm going to divide by 5. And I get y equals negative 2/5 x. So notice it does not have a b. You're like, so where do you put your point if you need a b? Well, it's actually plus 0. So on the y-axis, you're going to put a point at 0. Now be careful here with the negative slope. Just because the number is negative doesn't mean you go down and to the left. In fact, negative 2/5 is the same thing as negative 2 over positive 5. Negative divided by positive is negative. So in order to do a negative slope, you're either going to go down and to the right or up and to the left. You do not get to use the negative twice. There's only one negative symbol. You only get to use it once. So we're going to go down 2 and to the right 5. And connect the dots. All right, graphing horizontal and vertical lines. It took me a while to figure out why students get this wrong, and they get it wrong every single time. And I believe the reason why is because they see this line going like this, and they say, aha, the x-axis goes like this, therefore it must be x equals some number, like 5. Well, unfortunately, that doesn't work. That process is the opposite. Your logic is incorrect. So if you got a line going like this, the x-axis goes like this, it's actually y equals some number like y equals 3. Okay? So it goes opposite of what the axis does. So if you have y equals, then you're going to have a horizontal line which is opposite of what your y-axis does. Opposite, opposite, opposite. Same thing with the x-axis. Here's your x-axis. Here's your x equals. X equals, I don't know, 7. Okay? So it says x equals, it's going to be a vertical line. It says y equals, it's going to be horizontal. So if I need to graph y equals -4, it's going to be a horizontal line. Y-axis goes like this. Y equals goes like this at -4. X equals 2. Here is the x-axis, so x equals 2 goes opposite at an x value of 2. Another way of looking at slope, we can call it rate of change. That's usually in word problems. We call it rate of change. The graph shows the number of U.S. men and women living alone. Find the slope of the line and what does it represent. So we need the slope of the line for women, and that's this one right here. Okay, so we take our y values and subtract them, and we take our x values and subtract them. And I don't have a calculator handy. I'll go to the next slide in just a minute. So we'll figure out what that number is. But it says describe what the slope represents. So what did we talk about on top? That was the y values. That's the number living alone. Okay. And then the number on the bottom, that was years. So the way we describe slope is whatever's on top, living alone, per whatever's on the bottom, which is the year. So whatever unit is on top per whatever unit is on the bottom. And it's always going to be time on the bottom. So if you were to calculate the slope, this is one of the few instances where I would want a decimal. So it would be 0.22, and figure out what it actually means. 0.22 per year. Okay, this is in millions, so you'd multiply this by a million, and you would get 220,000 per year. Find a function that models the data for C, which is cars. What they're asking you to do is actually write the equation. So you need to know what m is. That's slope, so you would calculate your slope, and you need to know what b is, and that's going to be on the y-axis. So whatever number is on the y-axis, in this case it's 9, and then you would calculate the slope. So real quick, the 0.09 is on the y-axis, so your b is equal to 9. We would find the slope between those 2 points. And so here is your function. I know I'm doing that quick, but I wanted to stop the video before it went on and on and on. So here's your homework.